Okay, here's another exam question for 4 marks, standard one. Again, using the reverse chain rule, but looks a little awkward because of the denominator. But let's have a look and see how we can deal with this. Let's do the math. Okay, so part 1, given that some function of x is equal to 2x cubed plus 4x, find f prime of x. Well, let's get started. So part 1, and let's change again the thickness. Okay, that should be better. Part 1, we've got some function of x, f of x, is equal to 2x cubed plus 4x. 2x cubed plus 4x. And f prime of x then, f prime of x will be equal to 6x squared plus 4. So that's nice and easy, 6x squared plus 4. And using the reverse chain rule, and this time write it out, f prime of x divided by f of x dx will be equal in this case to log of f of x plus c, will be equal to the log of some function of x. I'm looking to employ that, some function of x plus c. Okay, now let's just say that 6x squared is equal to, so we've got 6x squared plus 4 will be equal to 2 brackets 3x squared plus 2. 3x squared plus 2. So now yeah, that's it, using the rules there. So 6x squared plus 4 will factorize to 2 times 3x squared plus 2. And that's part 1 done. Part 2, we've got the integral then of 3x squared plus 2, 3x squared plus 2 over 2x cubed plus 4x, 2x cubed plus 4x, which will, dx of course, which will be equal to, now we've got a half, we've got to compensate, that's the word that some people use, compensate, so we take it out, so it's 1 over 2 is equal to, now what did we get? 2 brackets 3x squared plus 2, 3x squared plus 2. And the 2 is an adjustment here. Again, some people use that terminology. Compensate and adjust. So this is the compensation, and I'll change the in red. This is the compensation, and the 2 is the adjustment. So yeah, the 2 is the adjustment. So compensation and adjust. And this is the adjust. Adjust. Oops, let's see, it should be a T there. Adjust. And this one, compensate. Comp. Yeah. And that's the terminology that is often used. So what do we have? We have equal to a half times the integral then of 6x squared plus 4. 6x squared plus 4 over 2x cubed plus 4x over 2x cubed plus 4x dx. And we move down, and that will give us yeah, 6x squared plus 4, that's correct, over 2x cubed plus 4x dx. And that will give you, now we did mention this before, a half, and this will be natural log of 2x cubed plus 4x, 2x cubed plus 4x, that denominator becomes the function, and then of course plus c. Plus c. And there you have it. Use of the reverse chain rule again to solve the integral of 3x squared plus 2 over 2x cubed plus 4x dx. And that's for 4 marks. Okay, the next question is involving integration by parts. And it does say integration by parts to find, in terms of E, the exact value of integral with limits 1 to the 0, 5x minus 4 brackets e to the 3x. So let's have a look at that, and that's for 6 marks. So let's not panic, and let's see what it involves. Right, I've got to get my pen to work. So we've got to show that with limits 1 to the 0, of course, we need to write it in terms of integration and show how we tell the examiner we know what we're doing. So, integration by parts, we write out the integral. So it's the integral. Again, my pen thickness is too thick. Here we go. The integral of uv, and we put a little prime there, dx is equal to uv minus the integral of vu dx minus the integral of vu prime dx. Can also be written v minus the integral of v du dx. Let's have a go at the maths. So we've got the integral of 5x to the minus 4, of 5x to the minus 4 e to the 3x. E to the 3x, that doesn't look much like a 3. Let's do that again. E to the 3x. Okay, dx. And that's equal to, and we can say 1/3, that's going to be 1/3, 5x to the minus 4. 5x minus 4, e to the 3x. And let's move this out of the way. E to the 3x minus the integral of 5 over 3 e to the 3x, of 5 over 3 e to the 3x dx, e to the 3x, and then dx. Okay, we need some more space, so if I put the equal sign over here, and so we don't get squashed up, that will give me, because if u is equal to 5, by the way, u is equal to 5x minus 4, and v will be equal to 1/3 e to the 3x, 1/3 e to the 3x, and so du dx du dx will be equal to, or u prime will be equal to 5, and dv dx will be equal to, or v prime, dv dx will be equal to e to the 3x. E to the 3x. And that's, of course, u prime is equal to, and v prime is equal to. Doesn't look much like prime, not to confuse you. Yeah, v prime, that is, which is the same as dv dx and u prime du dx. Now, this will go, going back here, so following on from that there, 1/3 5x minus 4 e to the 3x minus the integral of 5/3 e to the 3x dx. That will give you 1/3 5x to the 5 brackets 5x minus 4. It's late at night, getting tongue tied. E to the 3x, e to the 3x, minus, now we've got 5/9, because 3 times 3, or 1/3 times 5/3. 1/3 times 5/3 will give you 5/9, and e to the 3x plus c. E to the 3x, and then plus c. Which gives you, if we take out 1/9, 1/9, and then that will factor out 3, and then 5x to the minus 4, e to the 3x, minus 5e to the 3x, minus 5e to the 3x, because I've taken out a 9th. And of course, that's in brackets and plus c. That looks okay, and I can handle that. That will give me 1/9 e to the 3x, e to the 3x, brackets 15x minus 17. 15x minus 17 and plus c. And that is an x. Doesn't look like it, but I'm going to make it look like it now. There you go. Excuse my writing. And that's that part done. So that's integration by parts. And of course, I've used the chain rule to compensate, and reverse chain rule as an adjustment. So let's have a look at the integration then with limits, and I'll explain what I've done. So the integration with limits, let's call it I, is equal to integral of limits 1 and 0. Now substitute, so we've got 5x minus 4 e to the 3x, e to the 3x dx is equal to, and we put that all in, and that will give me 1/9 e to the 3x, e to the 3x, and 15x minus 17 in brackets 15x minus 17, close brackets and brackets again, with limits 1 and 0. And what do we have? Well, that will give me, I'll write it out, even though you could put everything now in your calculator. We've got e to the 3, and then 15 minus 7, 17, 15 minus 17, got to be careful here, taking a lot of time, so we don't want to make too many mistakes. 15 minus 17, close brackets, and again, and minus, open brackets, e to the 0, and 0 minus 17. Yeah, that's 15x minus 7. And close brackets again. And of course, e to the 0 is equal to 1. So we need to extend the page, and that gives us, let's tidy up. We've got 1 over 9 brackets minus 2e cubed plus 17. Yeah, and that's our answer. Or we could simplify it to say 17 minus 2e cubed all over 9. And that's the job done. Now, it's important to note here, so I put a little note just to, because maybe I went through it a little bit quickly, and please note, the derivative, and I try and, derivative, ddx of, oops, I don't want to put equals, the derivative of e to the 3x, of course, is equal to 3e to the 3x. And that's via the chain rule. Yeah? That's via the chain rule. And therefore, the integral of 5 over 3e to the 3x dx is equal to 5 over 3 times the integral of e to the 3x dx. So, which is equal to, which gives 5 over 3 times a third, 5 over 3 times 1/3 times the integral of 3e to the 3x dx. That's the adjustment and compensation made. And that, of course, that's where I got the 5 over 9 times the integral of 3e to the 3x dx. And of course plus c. So just a little note there to clarify where a lot of that working came from. Should extend and just finish up. 5 over 9 you'll end up e to the 3x, and of course plus c. So that's the reverse chain rule, of course, as well. Again, we seem to like that, so that's a part 3 of the reverse chain rule, and this is all for 6 marks. A standard question, really, but lot there, and sometimes viewed as a little bit tricky, but can be done if you use the rules and the procedures that are given to you. And this is in chapter 11 of your year 2 pure maths. Okay, that's it.